Yeah. This is going to be kind of like what we did very first day of class, and that is if we have 3a, this is a monomial, M-O-N-O-M-I-A-L. I think I spelled that right. Mono means one, of course, one number. Even though there's two things here, they're not separated by a plus or a minus, so it makes it one number. Now, if we have 8a plus 2b, what is this? Okay, those are separated by a plus, so there's actually two numbers. This is also what we call a term, right? And this is a binomial, bi meaning two, B-I-N-O-M-I-A-L. Bicycle, biplane, bilingual. Okay, there's two terms here. This is also an expression. But we talked about that earlier in the year. And then if we have, say, 3d squared plus 2e minus 5c, this is a trinomial. N-O-M-I-A-L. Tri meaning three, 1, 2, 3. And if there's more than that, and there can be, that's just called a polynomial. And a trinomial is also an expression. S-S-I-O-N. Okay, so how do we add and or subtract polynomials? Polynomials just means more than one number, many number. Poly means many. So if we have this 3a plus 2a, these are like terms, and again, we did this day one in here, I'm pretty sure. They have to have the same base number or the same variable and the same exponent. The exponents are 1, we just don't write it. And that is 5a, right? Right. And if we have let's see, 6c squared plus 2c plus 8c squared. Okay, these two are like terms. This one is not. It doesn't have the same exponent. So this is going to equal 14c squared plus 2c. It's super duper whiz bang important, but I think we've done it before. And if we have a negative 7d squared plus 10d plus 6, is there anything we can combine? Excuse me, anything here we can combine? No. They're all different terms. This is a trinomial with no like terms. And we have the same variable here, but the exponents aren't the same. So this is negative 7d squared plus 10d plus 6. There's nothing else you can do here. Right? Right. Now, if you wanted to evaluate a polynomial, evaluate means nothing more than find the value of it. But you're going to see this word on the final exam, and you're going to see it when you get to college algebra. Okay, evaluate polynomials. P-O-L-Y-N-O-M-I-A-L-S. Evaluate polynomials. Poly just means many numbers. So if you have 3x plus 10. Evaluate, B-A-L-U-A-T-E, for x equals 5. Now really all we do here is wherever there's an x, we're going to plug in 5. So it's 3 times 5. And when there's no plus or minus in between here, it means to multiply. Plus 10. Now remember order of operation. Order of operation, probably the most used thing we do in math. 3 times 5 is 35. No, it's 15. And then we do addition and subtraction last, so it's 25. I'll give you a hint here. You can put this in your calculator and it will do it for you. It does order of operation for you. So what if we have this? 3x squared plus 5x minus 10. Evaluate for x equals 4. Okay, again, wherever there's an x, we're going to plug in the number 4. So 3 times 4 squared plus 5 times 4 minus 10. Okay, again, order of operation. What do we do first? Parentheses. There's nothing to do in the parentheses, so we go to the next thing is, excuse me, exponent. So we do 3 times 16. 4 squared is 16 plus 20 minus 10. 3 times 16, I think, is 48 plus 20 minus 10. Okay, so that's 68 minus 10 is 58. Now again, you can put this in your handy dandy graphing calculator and it will spit out the answer for you. First thing, you turn it on. So you do 3 times 4 squared plus 5 times 4 minus 10. Is that right? Yes. Equals 58. Oh, say it. Say it. Oh, Johnny, what a smart boy you are. Okay, this calculator's your friend. Just make sure when you put this in, just take a second and look it over and make sure that you put it in correctly. You guys have big fat fingers. You ladies have long fingernails. You're going to hit the wrong keys. You got to have fingers like a spider to work one of these things. Okay, now what if we have the same polynomial? 3x squared plus, stupid, 3x squared plus 5x minus 10. Golly, what is the matter with me other than being stupid? Evaluate for x equals -2. Okay, so we have 3 times -2 squared. And whenever you have a negative number and you're going to put an exponent with it, be sure and put it in parentheses. Plus 5 times -2 minus 10. Okay, again, order of operation. So we do 3 times -2 times -2 is a +4 minus 10. 5 times -2 is -10 minus 10. So we have 12 minus 10 is 2 minus 10, which is -8. But again, if you have a negative number raised to a power, make sure and put it in parentheses. Because what if you have this? What if you have -2 5 squared. What does the calculator think this means? The calculator thinks this means subtract 5 squared. Let me show you. You put negative 5 squared. It's going to do order of operation. So it's going to say it's negative 25. Oops, sorry. Negative 25, which it is not. However, if you put negative 5 in parentheses, open parenthesis, negative 5, close, squared, now it's going to be positive 25. Because what does this say? This says negative 5 times negative 5. The base number is negative 5, and we're going to multiply it times its own self twice. Okay? Okay. Now, these problems, they really don't get any more difficult. They just get longer, like we said over and over and over and over. Oh. Okay, now what if we have this? Get this up here so smart. 6x cubed minus 4x squared. Are these two like terms? No. Remember, the exponents have to be the same also. Plus 3 plus negative 2x cubed plus 7x squared minus 5. Okay, when you look at this, I don't know about y'all, but my brain collapses when I see this. No, I can't do this. It's too long. I can't do it. Plus the fact I'm stupid. Where's Mr. Moore? Whose turn was it to watch after Mr. Moore? Ms. Morse, was it you?
Not today.
No, not on Thursdays when the moon is waxing or waning, whatever. Okay, this is real simple. It really is. But you look at it and think, holy crap, I can't do this. We look for the same base number and the same exponent. Here's x cubes. Here's x cubes. There's x squares. Here's x squares. There's a constant. There's a constant. So we're going to, first of all, add these two together, or combine these two. 6x cubed minus 2x cubed is nothing more than 6 minus 2. Right? Right. So we have 4x cubed. Is everybody with me here? This is very, very important. Okay, now we look for the squares. Here and here. Negative 4x squared plus this is nothing more than 7 minus 4, which is written backwards. So that, what is it, 3? Plus 3x squares. 3 minus 5 is a negative 2. Okay, so real simple. I have to underline because I'm stupid. Okay. Ms. Morse is back there saying, he sure is, and I'm telling Dr. Jones on him, he curses in class and he's stupid. Yeah, well, you just go right ahead. I mean, no, don't. Dr. Moore's very busy. There's Mr. Moore. Mr. Moore, where have you been? Miss Morse was crying and crying. Where's Mr. Moore? Where's Mr. Moore? Okay.
I'm here.
I see you. How are you doing?
I'm here.
You're not blessed tonight?
No, I'm here. He must be mad at me.
Okay, what if we have this? Here, Mr. Moore, let me go over this one again. This first This is called a polynomial expression. Why is it called polynomial? Poly means many, nomial means numbers. So if we have 6x cubed minus 4x squared plus 3 minus 2x cubed plus 7x squares minus 5. Now remember, in order to combine like terms, they have to have the same variable, same base number, and the same exponent. They have to have the same exponent also. So we have x cubes here and negative 2x cubes here. Those are like terms. X squares here and here. Here's a constant and there's a constant, just numbers. Now, this is nothing more than, because they're both x cubes, this is nothing more than 6 minus 2, which is 4x cubed. Now we did the same thing with the squares. 7x squared minus 4x squared. It's just 7 minus 4. It's just written backwards. Plus 3x squared. Right? Right. And then 3 minus 5 is a negative 2. And nothing else we can do there. Okay? Now what we did before you came at Mr. Moore was also very important. And you're going to see this on the final probably a couple of times. If we have 3x squared plus 2x minus 10, it's going to say evaluate this expression or this polynomial, same thing. E-V-A-L-U-A-T-E, evaluate. Just means find the value of, find out how much it is. Evaluate for x equals negative 3. So wherever there's an x, we're going to plug in negative 3. So we have 3 open, negative 3 closed, squared. Whenever you have a negative number raised to a power,
Right.
you put it in your calculator, be sure and put it in parentheses.
Okay.
Plus 2 times negative 3 minus 10. Now I'll tell you, you can put this in your handy dandy calculator and it will do this for you. It's just order of operation, and your calculator will do order of operation for you. This is 3 times negative 3 times negative 3. Let me do it over here. Negative 3 all squared means negative 3 times negative 3, which is a positive 9. Negative times a negative is a positive. 3 times 9. And then 2 times negative 3 is negative 6 minus 10. So we have, now we do multiplication first, 27. Now we can go ahead and combine these two. Minus 16 is, what is that, 11?
Right.
Or as I said, you can put this in your handy dandy calculator. First you turn it on. Okay, and this is very important. If you do 3 times open parenthesis negative 3 close. We do that because otherwise, well, let me go ahead and finish this. Negative 3 squared plus 2 times negative 3 closed minus 10, and it should be equals 11.
Right.
Now, if you don't put it in parentheses, remember that the calculator does order of operation. What does the calculator think this means? It means the calculator is going to think subtract 5 squared. So if you put this in the calculator, you're going to get negative 25. It's going to say subtract 5 squared. But if you put it in parentheses, it means -5 times -5, which is a positive 25. So if you're going to have a negative number raised to an exponent, be sure and put it in parentheses.
Right. Okay.
Okay? And take your time. You got this great big fingers of yours, Mr. Moore. Be sure and look on here and make sure you entered it right. You guys have big fingers. You ladies have long fingernails. You're going to hit the wrong keys. It's going to happen. Okay, now what about this? If we have 5a minus 2 minus stupid boy, minus 3a minus 8. Now what does this mean? It means to subtract this from this. Actually, there's a 1 here. We just don't write it. So we're going to multiply -1 times everything inside here. And really all that does is, there's not a 1 there, but so we have 5a minus 2. So really what happens is we just change all the signs over here because it says minus all this misery. Minus 3a plus 8. Okay, a negative times a positive is a negative, and a negative times a negative is a positive. Did I say that right? A negative times a positive is a negative. Now, excuse me, now we combine like terms. 5a's minus 3a's, -2, and 8. This is nothing more than 5 minus 3. They're the same base number, same exponent. So we have 2a, and then 8 minus 2 is 6. Is there anything else we can do there? No. Did we already do the distributive property of multiplication earlier in the year? I thought we did, but see, the next class after this one is 0310. And I'm telling you, you're going to see the same stupid stuff again in 310. So what if we have this? 4x open 3x plus 2. This is called the distributive property of multiplication. We haven't done this?
I think we did.
I think we did too. Look, let's just take this x out of here. Let's do this. It's a little bit easier. 4 open 3x plus 2. Now remember, the parenthesis makes this one number. But there's 2 numbers inside there. Okay, so we're going to multiply 4 times everything inside. We're going to distribute the 4 over everything inside here. So that's going to be 12x plus 8. 4 times 3 is 12x, and 4 times 2 is 8. The distributive property of multiplication, super duper whiz bang important. Very, 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 very important. Now, what if we have this? 4x open 5x, it's an x here. 5x, I think my handwriting's getting worse. Plus 3. Same thing here. We're going to multiply 4x times everything inside the parentheses. 4x times 5x is 20x, excuse me, x squared, because remember, x times x is when we have same base numbers and we're multiplying, we add the exponents. Didn't we do this last time? Yes. And then 4x times 3 is 12x. Can we combine these two things? No. They're the same variables, same base numbers, but the exponents are not the same. Okay, what about this? What if we have 2a squared open 4a minus 6? Okay, we're going to take this. This is actually one number because they're both together like this. This is a monomial. And we're going to multiply that times everything inside. 2a squared times 4a is 8a. Now remember, when you multiply and you have the same base number, we add the exponents. 2 plus 1, right? And 2a times a negative 6 is a negative 12a squared. Any questions here? This is not going away. This is very, 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 very important. These problems, they really don't get any more difficult than this, just like we've said all semester. They just get longer. Evidence. 5a cubed open. 2a squared minus 3a plus, come on, stupid, think, 4. Same thing, just longer. We're going to take 5a cubed and multiply it times everything over here. 5 times 2 is 10. A, we're the same base number. We're multiplying, so we add the exponents. Right? Right. 5a cubed times a negative 3a. 5 times negative 3 is negative 15. A, now we have a cubed times a, so we add the exponents to the 4th power. Right? Right. And then 4 times 5a cubed is 20a cubed. Are there any like terms here? No. This is to the 5th power, the 4th power, and the 3rd power. They're all different exponents. Remember, for them to be like terms, they have to have the same base number and the same exponent. Is everybody okay with this? This is not going away. You're going to see this a whole bunch, but thankfully it's very easy. Okay. Now, get this up here so smart. 3b plus 2 times 2b plus 5. Now we have two binomials. We're multiplying. So what we do is we take 3b and we multiply it times everything over here. 3b times 2b is 6b squared. And 3b times 5 is a plus, what is it, 15? 15b. Now we distributed the 3b times everything over here. Now we do the same thing with the 2. 2 times 2b is 4b, and 2 times 5 is 10. Middle two terms are typically common, or like terms. So we have 6b squared. 15b's and 4b's are 19b's. Everybody with me here? Am I going too fast? Everybody okay? Mr. Santhan's asleep. Somebody get Mr. Santhan a pillow.
No, sir, I'm not. I'm just, there's a lot on my mind right now, and it's just a headache, that's all.
I'm being stupid.
Can you start from the beginning on that one?
The one thing I'm really good at. I'm sorry, say that again.
Can you start from the beginning on that one?
Sure. Yeah, this is very, very important, so thank you for asking. 3b plus 2 times 2b plus 5. Remember, the parenthesis makes this one number, so we're going to multiply this number times this number. The only thing is there's two numbers inside of there. So we're going to start out with the 3b. Multiply it by multiply it times everything over here. 3b times 2b is 6b squared, because remember, when we have the same base number, b times b is, we're going to add the exponents, 6b squared. Then we do 3b times 5, 15b. Everybody okay with this? Like I said, this is not going away. You're going to see this over and over and over again. But thankfully, it's real easy. Okay, now we distributed the 3b times everything over here. Now we're going to take the 2 and multiply it times everything over here. 2 times 2b is 4b. 2 times 5 is 10. The middle two terms, these are called the linear terms. Not really important right now, but it will be later. The two middle terms are common, so we have 6b squared. These are like terms, plus, what is it, 19? 19b plus 10. Everybody okay with this? Very, very super duper whiz bang important. Okay. Now, get this if you're so smart. 3b plus 2 times 5b minus 4. Now, this is where it gets kind of nasty, and it's got these godless negative numbers in it. But they're not really that hard. Okay, now we do the same thing. First, we're going to take the 3b and multiply it by everything over here. If you've ever heard of the FOIL method, first, outside, inside, last, that'll work when you have two binomials here, but if you have something larger than that, it doesn't work. So I'd rather you not even deal with this unless you really want to. 3b times 5b, we're going to multiply the 3b times everything over here, and that's 15b squared. 3 times 5 is 15, b times b is b squared. 3b times negative 4, we have a positive times a negative is a negative 12b. Is that right? My brain slips in and out of gear here. Now we do the same thing with the 2. 2 times everything over here. 2 times 5b is 10b. And 2 times negative 4, a positive times a negative is a negative 8. Middle two terms are common. So we have 15b squared. Now we have negative 12 plus 10. Signs are different, so you subtract, take the sign of a larger number. So it's going to be a negative 2b minus 8. Okay, and that's really about as difficult as I get with it when they have some of these negative numbers in them. They're really not that hard. Okay, this is not super duper whiz bang important right now, but when you get to, excuse me, when you get to 0310, it will be. If you have a plus 5 times a minus 5. You can see they're exactly the same, except one's a positive, has a positive constant, and this one has a negative constant. This is called a conjugate. Like I said, this is not important right now. U-G-A-T-E, conjugate. Now what happens? A times A is A squared. A times negative 5 is negative 5A. Now we do the same thing with the 5. 5 times A is positive 5A. And 5 times negative 5 is negative 25. Middle two terms are common. Now what happens to the middle two terms? Or they're called the linear terms. 5A minus 5A is 0. They cancel out, minus 25. You're going to want to look for this. It is the difference means subtract, the difference of two perfect squares. When you have the difference of two perfect squares, you're going to get this. A plus 5 and A minus 5. Again, called a conjugate. And we'll be using that quite a bit in 0310. Okay. Let's see. What else do we have here? What if we have this? B minus 6 in parenthesis, all squared. What does that mean? Remember, the parenthesis makes this one number. And the exponent means that we're going to multiply this one number times itself. As my ex-wife would say, twice. B minus 6. B minus 6. Okay? I'm going to rewrite this down here. I'm sorry, but I have a personal problem with wasting paper. I don't know what it is. B minus 6 times B minus 6. Okay, again, the first thing we do is we take the first number inside here and multiply it times everything over here. Distribute it over here. B times B is B squared. B times negative 6 is negative 6B, right? Now we do the same thing with the negative 6 times everything over here. Negative 6 times B is negative 6B. Negative 6 times negative 6 is a positive 36. Middle two terms are common. Am I going too fast? No? Okay. B squared minus 12B plus 36. Anybody see the relationship? Now, I've been doing this misery for, I don't know, probably over 20 years. I've never had anybody see the relationship between them. I guess it's really kind of odd. Anybody see the relationship between this and this? It's 3 times that, right? But that doesn't always work. Half of 12 is 6. 6 squared is 36. It doesn't come into play very much here, but it will later. And scratch your back. Oh. Oh. Oh, that feels good. Oh. Okay. Let's take a few minutes and review what we did last week. Tuesday. When we have a squared times a to the 5th. When we multiply and we have the same base number, what do we do here? We add the exponents. A to the 7th. right? Everybody remember this from Tuesday? And if we have 3b to the 4th times 4b to the 5th, don't forget you have to multiply the 3 times the 4, which is 12b to the 9th. We add the exponents. Same base number, so we add the exponents. Now, what about division? If we have c to the 5th over c to the 8th. No. I'm sorry. C to the 8th over c to the 5th. Stupid boy. C to the 8th over c to the 5th. Now, when we multiplied, we added the exponents. When we divide, what are we going to do? Subtract. So this is equal to c to the 8 minus 5, right? Which is c to the 3rd. So we subtract the exponents when you divide. Now what if you have d to the 4th over d to the 6th? Same thing here. This is going to be equal to d to the 6 minus 4. Now we have to have a 1 in the numerator here. So this is going to be equal to 1 over d squared. Now we could also have done this d to the 4 minus 6, which is d to the negative 2 power. But remember, they're always going, well, always is a long time, but they're typically going to ask you to evaluate these with all positive exponents. So how do we do this? Remember, we draw a fraction bar. This is over 1. Now, when the exponent is negative, move it. When the exponent's negative, move it. If it's in the numerator, put it in the denominator, and then it becomes positive. But don't forget, you have to have a 1 in the numerator there. Okay, and what if we have this? If we have a to the minus 2, b to the 3rd, c to the minus 5 over b squared, c to the 4th, a to the 5th. This looks terrible. It's really not. It really isn't. Draw the fraction bar and go one at a time. If the exponent is negative, move it. Okay, a to the minus 2, where is it going to go? To the bottom, and becomes positive. B cubed is already positive, so it stays there. C to the minus 5 goes to the bottom, to the denominator, and it becomes positive. B squared stays. C to the 4th stays. Oh, can you be more stupid? C to the 4th and a to the 5th. Now, here's a squared and a to the 5th. So it's going to be a to the 7th, c to the 9th. Is that right? Now we have b squared on the bottom and b cubed on the top. Okay, 3 minus 2. So we're going to have b to the 1st power, 3 minus 2, over c to the 9th, 8. Stupid boy. a to the 7th. Remember, largest exponent first. They're the same exponent, alphabetical order. Then drink. Can we do another one of those? Boy, I cleaned out my water pipes with CLR. Now my drink tastes like CLR. So if I die before next time, you'll know what happened. Okay, let's do another one of these real quick and then we'll go. D to the minus 3, E to the minus 2, G to the 5th over E to the just E times D to the minus 4, G to the minus 3. Again, draw the fraction bar and then take them one by one. D to the minus 3 goes to the bottom and becomes positive. So it's D cubed. E to the minus 2 again goes to the bottom and the exponent becomes positive. G to the 5th is already a positive exponent. E it has a positive 1 for an exponent, so we just keep that. D to the minus 4 goes to the top. G to the minus 3 up here. Now, like terms. G to the 5th and G cubed is G to the 8th. Because remember, this is all multiplication. D to the 4th over D cubed, E cubed. And do we have anything else? Yes, the D's. So it's going to equal G to the 8th. D, there's 3 D's in the bottom and 4 on the top. So it's going to be just D to the first power, 4 minus 3, over E cubed. Is that right? I think so. Oh, I'm sorry. One more thing. I'm sorry. I promise. Well, maybe not promise. Well, what if we have this? What if we have a squared b cubed over c to the 4th d squared in parentheses, all raised to the negative 2 power. You're going to see one of these on the final. It might be a little bit longer than this, but it's the same stupid stuff. Now, when we have a power raised to a power, it's called, oddly enough, called the power rule. We're going to multiply the power on the outside times every one of the exponents under here. So it's going to be a to the minus 4, right? B to the minus 6. And you're going to multiply the exponent times all the other exponents over c to the minus 8, d to the minus 4. Okay, draw the fraction bar and take them one by one. I have a to the 4th in the denominator, b to the 6th in the denominator, and then c to the 8th in the numerator, and d to the 4th. Okay, it's called the power rule. Real simple. When you have a power raised to a power, you multiply the exponents. Any questions? Thankfully, this misery here is going to go away at some point, hopefully. And we'll never see it again. Okay, please be safe over the spring break. Over the years, I've lost several students from automobile accidents. Man, oh man, that is tough. Please, you know, my significant other, she said, no, I don't want to fly in an airplane. It's just so dangerous. I said, Jane, you got a much better chance of dying in a car wreck on the way over to the airport. If you need more practice, if you bought a book, look in there. Otherwise, stand up, plug your chairs in, and go away. I'll see you on the, what is it, the 23rd? Okay, y'all take care. Stop.